Welcome to today's class on cardiac cycle. So as we know that heart is the main pumping organ of circulatory system. So contraction of the heart works by contraction and relaxation. So one contraction of the heart is called systole. So whenever the heart contracts, that condition is called systole, and relaxation of the heart is called diastole. So heart contract ceaselessly, that means it contract non-stop rhythmically throughout the life, and this contraction include systole and diastole. That means this working of the heart, or you can say pumping of the heart, it include systole and diastole. So systole, what is systole? Systole is contraction of the heart, and what is diastole? It is a relaxation of the heart. One systole and one diastole, they combinedly constitutes one heartbeat. So one systole and one diastole, it makes one heartbeat. The cyclic repetition of various changes from one heartbeat to another heartbeat is called cardiac cycle. Now, which type of changes occur during cardiac cycle? As we know that heart one time contracts and one time relaxes during one heartbeat. So whatever the changes occurring in the heart, or you can say in the chambers of the heart, or in the wall of the heart, so all that changes, they are repeated in a cyclic pattern during every heartbeat. So cyclic repetition of various changes occurring in the heart from one heartbeat to next heartbeat, that sequence or that repetition of sequence is called cardiac cycle. So it is a cyclic repetition, so hence it is called as cardiac cycle. So during every heartbeat one systole and one diastole occurs, and as we know our heart beats 75 times per minute. So on that basis we can say that one heartbeat can be completed in 0.8 second. This is approximate time, but it is considered that one heartbeat is completed in 0.8 second. Now cardiac cycle includes four major events, out of which these are auricular systole, auricular diastole, ventricular systole and ventricular diastole. So as we know that auricle heart contract and relaxes one time during one heartbeat. So all the chambers of the heart, they contract one time and relax one time. So contraction of the auricles is called auricular systole, relaxation of the auricle is called auricular diastole. Likewise, contraction of ventricular wall is called ventricular systole, and relaxation of ventricular wall is called ventricular diastole. Each and every event of this cardiac cycle, it is completed in a particular time duration. The total, all these four events are completed in 0.8 second during one heartbeat. So every event has a particular time duration. So out of which auricular systole is completed in 0.1 second, auricular diastole it lasts for 0.7 second. That means one time when auricle contract, rest of the all time of one heartbeat it get relaxed. So time for auricular relaxation is 0.7 second, because we know that alternately the chambers of the heart, they alternately contract, auricular contraction then ventricular contraction, and one complete heartbeat include one total you can say events of auricle and one total events of ventricle. That means auricular systole, auricular diastole and ventricular systole, ventricular diastole. So 0.8 second, in this 0.8 second all these four events are carried out. So out of which auricle they contract only for 0.1 second. So remaining all the time of 0.7 second the auricle they relaxes. Meanwhile when the auricular contraction is you can say completed and auricular relaxation starts, at the same time ventricle contracts. The ventricular systole it occurs for 0.3 second. So ventricles contract in 0.3 second time duration, and rest of the time, that means remaining 0.5 second time, the ventricle they get relaxed. So in this way, auricular systole and auricular diastole, it is also completed in 0.8 second, and ventricular systole and ventricular diastole, it is also completed in 0.8 second. So if you calculate the auricular events, they are also completed in 0.8 second, and if you make a sum of ventricular events, they are also completed in 0.8 second time. So this is a diagrammatic representation. Here in this diagram we can see each, you can say, division of the circle. There are two concentric circles, and in each division of the circle, or you can say each segment of the circle, each compartment of the second circle is of 0.1 second time. So look at this here, this one part is of 0.1 second, another part 0.1 second. Likewise, these total circles, concentric circles, these are divided into 8 such you can say divisions, and each division is of 0.1 second time. So hence the time is also mentioned here, 0.8 second. The auricular, and also in this diagram, auricular and ventricular events are also shown. The red color indicates systole of various chamber, and the blue color indicates diastole of various chambers. Now let us see one by one, explain one by one the events occurring during this cardiac cycle. So firstly we are going to discuss auricular systole. So auricular systole means contraction of the auricles, and when the auricle will contract? Only when the auricles get filled with blood. Right auricle receive deoxygenated blood from precaval and postcaval veins. At the same time, left auricle receive oxygenated blood coming from you can say pulmonary vein. The cardiac cycle starts with auricle because the pacemaker is situated in right auricle. SA node, pacemaker means SA node, which is situated in the wall of right auricle. So hence the cardiac cycle starts with the from the right auricle, and as we say that both the auricles they get filled with blood, right side get filled with deoxygenated blood and left auricle get filled with oxygenated blood. When both these auricles are filled, then the cardiac cycle is initiated, and this is initiated due to stimulation of SA node. So SA node, which is a pacemaker, it contracts or it releases a wave of contraction. That wave of contraction is spreaded throughout the auricles, and hence the auricular contraction takes place. So wave of contraction is generated at SA node, which then spreads to both the auricles, and auricles they contract and force. When the auricles contract, the blood is not returned back into the veins, because these opening of the veins, they are guarded by particular valves. So blood is not forced back into the veins. When the auricle contract, the blood is forced into the ventricle below chambers, that is ventricles. So auricles they contract and force the blood into respective ventricles through the AV aperture, which is present between auricle and ventricle. Auricular systole is completed in 0.1 second time. In the diagram also, the red part of auricular events, it shows auricular systole, which is completed in 0.1 second time. So this one is the auricular systole, and it is completed, look at this, it is completed in 0.1 second time. So this one is 0.1 second time, and remaining rest of the time it is the relaxation phase for auricle. So rest of the time auricular wall get relaxed and auricle start filling. So this is about the auricular systole. Then auricular diastole, it starts immediate after auricular systole. So when auricular systole is completed here, then auricular diastole starts. So it starts immediately after the auricular systole. Auricles they relax and receive the blood from precaval and postcaval veins. Again, as the auricle are now relaxing, they are also now receiving the blood from precaval vein and postcaval vein in right auricle and pulmonary vein in left auricle. So as we already said, slow the blood from body, beat by beat, stroke by stroke, the blood from the body, it is collected and carried up to right auricle through precaval and postcaval vein and into left auricle through pulmonary vein. The duration for auricular systole is rest of the time, that is 0.7 second time. Then next part, the end of auricular diastole and auricular systole begins. Again, you can see here now, remember, when auricular systole is completed, auricular diastole starts, and auricular diastole, when the auricular diastole ends, again the next auricular systole is repeated. That means the next cycle, cardiac cycle, is repeated. So hence this is a cyclic repetition: auricular systole, auricular diastole, then again auricular systole, then again auricular diastole. So likewise these events, they are repeated during every heartbeat or during every cardiac cycle. The next part, that is ventricular systole. So look at the diagram here. Whenever the auricular systole is completed, at the next immediate time the ventricular systole starts. So that means ventricular systole begins at the end of auricular systole. When the auricular systole is completed, ventricular systole starts. The wave of contraction which is generated in SA node from right auricle, it was first distributed in auricle, and as a result the auricles, they get contract during auricular systole. Now this wave has travelled down up to AV node, which is situated at the base of tricuspid valve. So that AV node is now stimulated, and this AV node then passes the wave of contraction down into bundle of His. This bundle of His then pass, or you can say supply, wave of contraction to Purkinje fiber, which later on initiates the ventricular contraction. Both ventricles, they contract simultaneously and forcefully, because the blood from ventricle has to be circulated up to distant organs. So hence ventricular contraction is forceful. However, the auricular contraction is less forceful than ventricular contraction, because auricle has to pump the blood only up to ventricle, but the ventricle has to pump the blood up to various part of the body. Hence the ventricular contraction is forceful. At the beginning, the AV wall closes. So when this ventricular contraction starts, or you can say immediate after auricular systole, when auricular systole is completed, when the blood is poured into the ventricle, immediately the AV valve, that means tricuspid and bicuspid valves, they get closed, and closing of this tricuspid and bicuspid valve creates a sudden sound called first heart sound. The sudden closing of tricuspid and bicuspid valve, it creates first heart sound, which is referred as lub, L-U-B, lub. This first heart sound, okay, it is heard due to closing of this tricuspid and bicuspid valve. The ventricular systole, it include three events: isometric contraction, then rapid ejection, and slow ejection. Now what are these three events? So ventricles or ventricular systole begins at the end of auricular systole. Auricles and ventricles, they never contract simultaneously, because firstly the wave is generated in auricles and then it is transmitted to ventricle. The beginning of ventricular systole, at the beginning of ventricular systole, there is a first heart sound, because there is closure of AV valves, and these ventricles, they now start contracting. But after closure of AV valves and beginning of contraction of ventricle, some time is spent. So no blood passes out of the ventricle and no blood comes in the ventricle. So before the contraction phase, or just the initiation of the contraction of the ventricle, there some time is passed, or this cardiac muscle, they take some time to contract. Cardiac muscles of the ventricle, they take some time to contract. So before you can say actual contraction of ventricle and after closure of these AV walls, the some second time 0.05 time is spent there, it is wasted there, and that 0.05 time where there is no contraction and when there is no, you can say, passing of the blood, so that time is called isometric contraction phase. Isometric contraction phase, it is carried out in 0.5 time. After isometric contraction period, the intra ventricular pressure rises above the aorta and pulmonary aorta pressure. So as the ventricular pressure rises, immediately the blood start rushing inside the aorta, pulmonary aorta and systemic aorta. So when the ventricles contract, the inner pressure of the ventricle, it rises, and this rising of pressure of the ventricular wall, it is more than the pressure inside the aorta. Hence the blood from ventricle, it is pushed, it rushed, or it is rapidly ejected in the systemic aorta and pulmonary aorta. So blood rushes into the aorta, and hence there is rapid ejection of the blood which lasts for about 0.11 second. So up to 0.11 second, blood is rapidly ejected from the ventricle. Then the ejection is slowed down, and the slow ejection period is of 0.14 second time. So during ventricular systole, the blood is pumped out of the ventricle, and this pumping of the blood out of the ventricle, it is completed in 0.3 second time, because ventricular systole occurs in 0.3 second time. The 0.3 second time of ventricular systole, it is divided into these three steps, or you can say it is divided into these three events. The isometric contraction phase, where there is no ejection, this is a time after closure of AV wall and before actual ejection. So that is isometric contraction phase, which is of 0.05 second. Then rapid ejection occurs, which lasts for 0.11 second, and then slow ejection takes place, which lasts for 0. You can say 14 second time. So if we make a sum of isometric contraction phase, then total ejection phase of rapid and slow ejection, which is of 0.25 second, if we make a sum of 0.11 second and 0.14 second, it is of 0.25 second. So total of these, or you can say sum of these events, it is completed in 0.3 second time, which is the actual time of ventricular systole. So this is regarding the ventricular systole. Then next phase, that is ventricular diastole. So as soon as the ventricles start relaxing, the ventricular pressure falls, because the wall of the ventricle are now, or you can say muscles of the ventricular wall are now relaxing. Hence the pressure inside the ventricle is reduced. As the pressure inside the ventricle reduces, the blood from aorta and pulmonary vein, it again try to come back into the ventricle. But at the same time, when the blood is now trying to come back into the ventricle, at the same time the valves which are present at the opening of these aorta, that are semilunar valves, and those semilunar valves, they immediately get closed, producing second heart sound. It produces second heart sound, which is referred as dub. So first heart sound, which was occurred due to closure of AV valves, and second heart sound, it occurs due to closing of, you can say, semilunar valves. So second heart sound is heard due to closure of semilunar valves. Now a short period from onset of ventricular diastole and closure of semilunar valves is called prodiastolic period, which is of 0.4 second time. Closure of semilunar valves and beginning of ventricular diastole, this is called prodiastolic period. When the semilunar wall get closed, the ventricles are also the closed, that is the ventricles are closed chambers, but still the AV walls are not opened. So hence the AV walls are also closed, Semilunar walls are also closed. There is no opening in the ventricles, so hence the ventricles are like a closed chamber. So they have not yet opened. Thus, during this short period, no blood enters in the ventricle, and this period is said to be the isometric relaxation phase. It is said to be the isometric relaxation phase, which occurs for 0.08 second. After isometric relaxation phase, at the end of isometric relaxation phase, the AV valves they open. Blood rushes into the ventricle and the ventricles get filled again. The filling of the ventricle starts, or you can say there is a beginning of filling of the ventricle due to opening of AV valves. Initially, at the first part of this filling phase, initially there is rapid filling of ventricle because the auricles are laden with the blood, and hence when the AV valves open, rapidly the blood rushes into ventricle. So first phase is rapid filling phase. As soon as the AV valves open, the blood which is accumulated in the auricles, it rushes into the ventricles. Due to this rapid rush of the blood, now immediately when the as we know that ventricles are empty, auricles are filled with blood, and the wall between auricle and ventricle, when it opens, immediately blood falls, it falls in the ventricle. So this falling of the blood in the ventricle, it creates third heart sound. That means first rapid filling, during first rapid filling, third heart sound is created. In the next phase of diastole, the rate of filling slow down. These ventricles are already full to a large extent, and the ventricle pressure slowly rises. Consequently, the rate of inflow from the auricle becomes slow. This period is called diastasis, or you can say slow inflow phase, or you can say slow filling phase. Okay. Then after this period comes the last part of ventricular diastole, which is the last rapid filling phase. Due to auricular contraction, the blood rushes into respective ventricles. So at the last part of ventricular diastole, again the blood at the last second, 0.1 second, last 0.1 second of ventricular diastole, on auricular phase or on auricular side, auricle again contracts. So auricular systole takes place. Still the ventricles are in relaxation phase, and at the last phase of ventricular diastole, the auricular systole takes place, and due to the auricular systole, rapid rushing of the blood from auricle, it occurs into the ventricle. So last phase of ventricular diastole is rapid filling phase, and this rapid filling phase is due to second cardiac cycle. That means due to second time contraction of auricles. So next cardiac cycle, part of the next cardiac cycle is overlapped in this part. So last rapid filling phase, which is of 0.1 second, due to this rapid rush of blood, again a sound is produced, which is called fourth heart sound. This also indicates that at the end of ventricular diastole, this fourth heart sound indicates the end of ventricular diastole. So all these four events, it occurs. Isometric relaxation phase occurs in 0.8 second, rapid filling phase occurs in 0.113 second, diastolic phase occurs in 0.13 second, and last rapid filling phase occurs in 0.1 second. So total of the ventricular events is here summed out as the prodiastolic period, which is of 0.5 second, isometric contraction phase 0.8 second, then first rapid filling phase 0.113 second, slow filling phase 0.167 second, and rapid filling phase 0.1 second. So sum total of all this is 0.5 second time. Now at the end of ventricular diastole, the impulse from SA node again reaches to the AV node, and again the ventricular events are repeated. So from the cardiac cycle it is very clear that at the end of ventricular systole the ventricular diastole starts. So that is the auricle and ventricle systole, they never overlaps. So when auricular systole is completed, then ventricular diastole starts again. If we go back to our diagram, here in this diagram we can see, here look at this diagram, here we can see from this it is clear that when auricular systole is completed, then only ventricular diastole starts. So auricular systole and ventricular systole, auricular systole and ventricular systole, they are not overlap. After completion of auricular systole only the ventricular systole will start, and for the period of 0.4 second time both auricles and ventricles, they are in relaxation phase. So which time is of 0.4 second time? Now look at from this time, from here at the end of ventricular systole, this 0.1 second, 0.2 second, 0.3 second and 0.4 second. This is the time period where both the chambers, auricles and ventricles, are in relaxation phase. So this, from this to this part, this part of the heart, or this part of the events of the heart, this is at during this time both the chambers, they are in relaxation phase for a complete period of 0.4 second time. This period is called diastole of whole heart. And last part to be remember, that is ventricular diastole after fourth sound overlaps the auricular systole. Here after fourth sound here ventricular diastole overlap the auricular systole. This one, you can say this part of the ventricular diastole, it is overlapping the auricular systole of the next cycle. So in this way cyclic event occurs during each heart beat and each cardiac cycle. So this is all about your cardiac cycle. Thank you.